really important, don't please get the idea that the name data-directed programming means you have a two-dimensional table that's used for keeping track of operators and operands. We are using data-directed programming for that purpose now, in today's class. But data-directed programming is a much more general idea. So back in the old days, it used to be that every company, we're talking about the days when computers were half the size of this auditorium and cost $1 million. So every company that wanted to use a computer would not only get a computer, they would hire a bunch of computer programmers. Because you couldn't just go to CompUSA or Best Buy and pick up, TurboTax or whatever. That whole software selling mechanism didn't exist, and instead everybody wrote their own software. So for instance, computers were mostly used for boring things like payroll, printing out the checks to the employees every month or every week or whatever. And each company had their own payroll program. Okay, today that seems really stupid. Today you would expect to go to the store and pick up something called payroll software and stick it in your computer and it would just work. Okay, why did each company have a separate one? Well, company A has 7-digit employee IDs. Company B has 4 digits plus a letter employee IDs. Company A pays every month. Company B pays every 2 weeks. Things like that, little things like that, meant that each company wrote their own customized to their situation payroll software. Okay? What changed that? It's still true that company A has 7-digit employee IDs and company B has 4 digits plus a letter. And it's still true that this one pays monthly and this one pays biweekly. What's different? When you use software, how do you deal with stuff like that? Right? What'd you say? I didn't hear. Sorry? Templates, sort of, yeah. Templates is a specific case about editing and stuff. Or, oh, I see, you mean like Java templates. Yeah, no. I'm talking about the guy in payroll who wouldn't know a Java program if it bit him. But he can still set up his payroll program. Why? Give you a hint. Preferences, yeah. So what's preferences? Well, it's a data file that tells the one generic payroll program how to deal with the particular needs of this particular company, right? That's data-directed programming. And it was the reason for the first big dip in the hiring of programmers, right? Used to be every company with a computer had a programmer or 2 or 3. And then it got to where you could be a company and use computers and not have any programmers on staff because you could use generic software courtesy of data-directed programming. Okay, so it's a big, important idea in the world. You'll see initialization files. Who runs Windows at home? Boo. On your computer, there are a bunch of files with names like such and such .ini. Stands for initialization. Those are data-directed programming files. Okay? Who runs Linux or Mac OS or any Unix thing? Okay, on your computer, there are a bunch of files called such and such .rc. Those are data-directed programming structures that tell programs how you want them configured. So this is used by pretty much every program in the world. Okay, there's an initialization file in which you can customize things. It's a very, very, very important idea. I am now going to show you the most interesting use of that idea. Okay, so this is an excerpt from something in the scheme reference document. This isn't the whole thing, it's just a little piece of it. And this is the formal syntax of scheme. This is a description of what a scheme program looks like. And it says, what does an expression look like? Well, it turns out that formally there are exactly 7 kinds of expressions. So when we looked at the little scheme interpreter, and I said there were 4 kinds of expressions, this is the same idea. So the first one is a variable, which we looked at as an expression type. Literal means self-evaluating. Procedure call is a procedure call. And the other 4 are special forms. And it turns out, according to this scheme standard, there are 3 sort of primitive special forms, lambda and cond, and one we haven't seen yet for assignment. And everything else, all the other special forms, are defined in terms of those. Okay? So what I want to look at right now is what does a lambda expression look like? It looks like an open parenthesis, followed by the word lambda, followed by formals, whatever that means, followed by body, whatever that means, followed by a closed parenthesis. So the thing in brackets, angle brackets, less than, greater than, those are sort of meta variables. They're not scheme variables, they're formal syntax variables about scheme. So we have to know what formals and body means. Formals is the formal parameters of the procedure, and it consists of open parenthesis, followed by 0 or more variables. And the 0 or more is what this asterisk means, followed by a closed parenthesis. So that's the syntax for a fixed number of arguments. Or a single variable not in parentheses, which means the variable number of arguments notation with no fixed arguments. Or this hybrid thing where we have open parenthesis, followed by 1 or more variables, which is what this plus sign means, followed by a dot, followed by a variable that's the rest argument, followed by a closed parenthesis, and so on. Okay? I'm not going to go through the rest of it, but this is the formal syntax of scheme. And back when this formal notation, which is called BNF, or Backus-Naur form, when it was first invented, it was just for telling people what the syntax of a programming language was. But today, you can get a program that you're not allowed to call a compiler, even though that's what everybody calls it, because Professor Hilfinger will get upset. So for him, you have to call it a parser generator that takes something like this as input and turns out a compiler for your language, whatever it is. So I can put this into a compiler, and out comes a scheme compiler. The reason Professor Hilfinger doesn't want you to call it that is that there's a whole other aspect to compiling which has to do with what do these forms mean. So knowing what a lambda expression looks like doesn't tell you what scheme should do with the lambda expression. And that comes from a formal semantics notation, which is the other half of it. Okay, but this half generates the parser, the thing that looks at stuff that you type in and figures out what kinds of expressions are involved. So now you basically write one compiler that's sort of the universal language compiler, and then you just write a BNF for whatever language it is that you want to compile. So this is the ultimate, I think, in data-directed programming. A big, big important idea.